Hi, my name is Eric Stinson. I'm with Juniper's product marketing team. With me, I have Vijay Paul, who is one of our directors of engineering. He is director of engineering on our Junos Evolved. Welcome. We're going to do a quick vlog today, introducing Junos Evolved and kind of what our goals were in developing it. Junos Evolved has evolved our Junos network operating system to be cloud optimized. The goals were to simplify network operations with a highly scalable, unified, end-to-end network OS while providing the reliability, quality, agility, visibility, open programmability, and simplicity to facilitate cloud operator success with a flexible and cost-effective network infrastructure at cloud scale. One important note, is this is an evolution. It's not a totally new operating system, meaning that the interfaces have remained consistent with our Junos OS to deliver one Junos experience end to end. So welcome, Vijay. I was just wondering if you could tell me a little bit about the core architecture of Junos Evolved and why we picked it.
Hi, Rick. Thank you for having this discussion. Like you said, one of the main considerations when we started off building this operating system ground up was you wanted to make sure that installation of the system into a brownfield environment where existing Junos devices sit is as seamless as possible, which is the reason why all the northbound interfaces on this operating system are identical to what Junos supports, which is to say the same management plane and the routing plane. Now, that said, there are certainly a lot of key aspects that we hold core and central to us when we built the system. We wanted the system to be ready to take on the next decade of networking, right, for Juniper. And we built the system with Linux native environment, which is to say that we run all the applications in a native Linux environment and all the goodness that comes with it. Along with that, we wanted to make sure that all the interactions in the system are component driven, in that you didn't want to build a monolithic system, and we'll obviously talk about it a little more as we go along. We also wanted to make sure that there's extreme visibility into what is going on in the guts of the system. This is with respect to making sure that we have more than adequate analytics and visualization possibilities on the system. So as we explore the system, you'll realize that there's a lot of elements that have gone into the design ground up that enable pervasive telemetry and visibility into all aspects of system state that goes on. Along with this, we also wanted to make sure that the system is designed in an unconstrained way where you no longer have bolted down the system to the confines of a chassis, which is to say you can take this operating system, run it inside Juniper devices or also out on general compute out in the cloud. And that opens up a lot of exciting possibilities in what's possible for distributing routing applications in a public or private cloud.
Yeah, well, yeah, you hit on quite a few interesting points there. One of them that you mentioned was being state-based. So, we implemented a formally modeled state-based publish subscribe communications infrastructure. Can you give us some details on that infrastructure and talk a little bit about the advantages that provides?
Yes, absolutely. So this is one of those things that I believe makes or breaks a network operating system, in that it defines what the performance characteristics are going to be, what the resiliency of the system is going to be. So the communications infrastructure was something that we spent a whole lot of time thinking about and being deliberate about, right? The choice we went with was what we call a state-based pub subsystem. This is different from other commonly seen publish-subscribe systems out there. It has the same benefits of a standard pub subsystem in that you have the lack of time coupling between the consumers and producers. The producer does not need to be aware of the consumer's location, so there is a location decoupling that you get. And these are important aspects that go into building resiliency in the system, right? It also has important properties in being able to take your applications and run them outside of the confines of the chassis. But at the same time, the most important thing that we wanted to be cognizant of is make this pub subsystem a state-based pub subsystem, which is to say that the unit of transaction on the system is not messages, right? Because fundamentally, our understanding looking at this problem is that you cannot put an upper bound on the number of messages in the system because the number of times a route can flap in a second, number of times an interface can change. Those are not things that you can control, right? So if you want a system that does not have unbounded queuing, you're going to have to be a little more intelligent in how you play this messaging infrastructure. So we essentially have a pub subsystem that is able to compress events, or rather compress state, so that we never run into a case where an external event is going to starve us for memory.
Yeah, absolutely. And, that kind of brings us into the next piece, right? So, events gets into some of the management pieces, and visibility is also obviously very important for network engineers, and particularly in the cloud environment. So can you describe, a little bit about, how we provide the required visibility?
Oh yeah, absolutely. This is something that I personally am very passionate about. This is something that all the core architects in the group rallied behind, because the intent was very selfishly to say that we want to build a system where you do not have to go back in later and put in probes or add logging to understand what's really going on. At the guts of the system, the premise always has been that the data ought to be exposed to infrastructure, not because there is a need today, but because the need can arise tomorrow, right? And we do that by making sure that all interactions in the pub subsystem are formally modeled, meaning the schema is fundamentally captured in a model that is inspectable, introspectable by the infrastructure layers. So every time a feature is developed on the system, automatically you get all the goodness. Right?
Yep.
You get the visibility for free, and you don't really have to lift a finger to do anything, because this is that fundamental.
Yeah, and that's key. And it's not just visibility within our own stuff, but any of the third-party applications that get integrated in there get to have some visibility as well, which is really nice. And that kind of brings us to another thing. Within the system itself, and then also, when you integrate in some third-party applications, security is also a key concern, as with anything. So, how does Junos Evolve help address some of the security challenges with a secure execution environment? Absolutely.
This is again a very interesting topic, because it would seem like two conflicting goals, right? You want security on one side, and also the flexibility necessary to modify software in the customer premises, right? There might be customers who want to bring in their own agents and applications, install them on the box, probably for monitoring reasons or various reasons that are private to really their deployment. Now, Juniper doesn't want to be standing in the way. So but at the same time, it's bad form to ship software that can be compromised and in ways that you cannot detect, right? So we've found the right balance here by making sure that we have infrastructure that allows the signing of Juniper supplied software in a way that ensures that the routing protocol that you're running in the system, if tampered with, will not run on the box, right? So you have guarantees that the software provided by Juniper is running untampered. But at the same time, if the customer wants to install their own applications, they can also do so with the same level of security by bringing in their own keys and signing. So that's a unique proposition that we bring with the system that provides, in my opinion, the best of both worlds.
Right. Yeah, no, absolutely. Because, that's the age-old, security conundrum. You want it to be secure, but you want it to be flexible and open. So, you gotta strike the right balance here. And it sounds like you've really done a good job with that.
They say you can't have your cake and eat it too. Here we do.
Perfect. So just, one last thing, this is built on a microservices architecture. And two of the advantages of a microservices architecture are improved software upgrades, as well as high performance scalable software. Can you talk just a little bit about that?
So this is again a very fascinating piece, right? If you look at most network operating systems in an unbiased way, right? No one wants to build a monolithic system. No one sets out to starting with a design goal to say, hey, I want to build this whole monolithic system. But somewhere along the way, you lose your way, right? You lose your way in not staying the course and recognizing that the system is ultimately comprised of individual subsystems, libraries, applications, which are all cleanly separated out into their own repositories, right? It's just that somewhere along the way, most systems lose the plot and aggregate and lump it all together in one monolith. What the Junos Evolved does is carries the version information of the libraries and applications right from the repository level all the way into the final bill of materials that gets shipped into the system. So this makes for a system where you have visibility into the granular versions of every subcomponent as exists in the source, right? Which makes it very interesting when it comes to doing things like smart software upgrades, right? So that's essentially one of the design principles that allows us to do software upgrades in interesting ways that are useful to the customers.
Yeah, absolutely. Well, we're kind of running short on time, Vijay. This has been, super interesting for me and very informative for me. Hopefully it has for everybody else listening as well. We will be following up with additional vlogs as well as some blogs to dig into some more detail. We just wanted to kind of give you a high-level overview of what we have going on here. So again, Vijay, thank you very much. This has been great.
Thanks, Rick. Pleasure talking to you.
Yeah, thank you. Have a great day.